So back to our original application of searching for values in a B-tree. Now remember, the biggest difference between the two is that the real data is actually stored at the bottom of the tree, which is going to be on a hard drive somewhere. It's not going to be in the memory like a binary search tree. Remember we created nodes and nodes and nodes that had complex data in it? That's not going to be the same for a B-tree. A B-tree is just going to use some type of key to represent, well, what direction we need to go to get to the data. Also, compared to a binary search tree, everything's going to be even, meaning that all of the search paths have the same exact length, which is log of n, to every single piece of data. That's the neat part about it compared to a binary search tree. I know you're saying, well, what about red-black trees? But remember, red-black trees, we had to create nodes of data, so there's still that. It might have been even, but that red-black tree is going to be huge. If we have a database in it, your computer may not be able to handle that. So this is one way of us basically breaking out of the red-black tree, the binary search tree, and be very similar to it, but also give us the freedom of, again, really dropping data into somewhere that's going to have much more storage than regular memory. Also remember that the keys, the directional set that we have, the keys are the ones that are going to be really helping us figure out where to go in the disk to actually find the the data. And then while we're searching through the structure itself, there's only three conditions that are really going to happen. If a node happens to be null, then it's not found and we return the null. If the node happens to be a leaf, then we search that list of values to see if we can find what we have. If it's not in there, then we return null because it wasn't there. And else, well, it's going to be an interior node. We use the key to find exactly where the subtree is and move to that portion next in order to get to that. So that's your three biggest conditions that you're going to have with the B-tree and the overall scenario for searching within a B-tree structure.